Hello, I am Moinak. And today we shall discuss about the applications of the uncertainty relation. In my previous video, we shall discuss the basic concepts of uncertainty relation. So we here today we shall apply the uncertainty relation in quantum mechanics to find we can apply it to the three things, that is to measure the minimum energy of a harmonic oscillator, Second thing, ground state radius and energy of hydrogen atom, ground state energy of helium atom. Number 4 is non-existence of electron in nucleus. Okay, here we can discuss about here we can today apply the uncertainty relation to measure the minimum energy of the harmonic oscillator, ground state radius and energy of the hydrogen atom, ground state energy of helium atom, and the non-existence of electron in the nucleus. Why electron cannot exist in the nucleus? Here we can see from the uncertainty relation. So first we can derive the minimum energy of harmonic oscillator. Okay, so first we apply the uncertainty relation to measure the minimum energy of the harmonic oscillator. We all know that the energy of a harmonic oscillator, total energy of a harmonic oscillator is p square by twice m plus half m omega square x square. We all know that the energy of a harmonic oscillator is related by this relation. P is the momentum, m is the mass of the bob or the oscillator, omega is the angular frequency, delta s is the displacement. Okay, so total energy can be written in this form: p square by twice m plus half m omega square x square. And we all know from uncertainty relation, we know that from uncertainty relation we know that this is delta x delta p, that is h cross greater. Actually this is greater or equals to, so we can here consider greater, because this minimum condition obtained when delta x delta p, here we can calculate the minimum energy. So actually delta x delta p, that is greater or equals to h cross. So one can easily ask why we cannot accept this sign greater than. Here we can calculate the minimum energy. So this relation minimum when this is equals to h cross, so we can consider equals to sign. Okay, so if we write this equation, in the uncertainty form, then E can be written as delta P square by twice m plus half m omega square delta x square. Here delta P is h cross by delta x, h cross by 2, we consider h cross by 2, so h cross by 2 delta x. So E here h cross square by twice m delta x square plus half twice m 4m 2 into 4 8m delta x square plus half m omega square delta x square. So in uncertainty relation, we derive from, if we write the equation in uncertainty relation, then the equation looks like this: h cut square by 8m delta x square plus half m omega square delta x the square, that is equals to E. So in uncertainty relation, this equation looks like that. Nothing here we can do is only we replace delta P, that is h cross by 2 delta x, and the equation looks like this. So this equation, this form of the energy only depends on delta x, because h cross is a fixed value, m is a fixed value, omega is a fixed value. So delta x only dependent on the positions uncertainty, So we wish to calculate the minimum energy of the harmonic oscillator. So we can differentiate the equation with respect to position uncertainty, and for the minimum energy, we know that del x, we differentiate the equation with respect to x equals to 0, del E del x. So if we differentiate this, that is nothing but h cut square by 4m delta x cube plus m omega square delta x, that is equals to 0. So h cos square by 4m delta x cube equals to m omega square delta x. So delta x to the power 4 equals to how much? H cut square by 4m square omega square. So delta x square is how much? H cut by twice m omega. So delta x is how much? Delta x is root over h by twice m omega. So if we put this value in this equation, in the given equation. So E, this is minimum energy, E mean. So E mean কত হবে? E minimum, that is h cut square by 8m delta x square is how much? H cross by 2m omega, 2m omega by h cross plus half m omega square. Delta x square is how much? H cross by 2m omega. So m cancel out, h cross can 1 cancel out, 2 cross 4, cancel out here, omega 1 omega. So this gives us h cross omega by 4, this gives us h cross omega by 4, this gives us h cross omega by 2. So E mean, minimum energy of a harmonic oscillator, is given by h cross by 2. H cross by 2. So E mean, E minimum, that is h cross, half h cross for ground state. So minimum energy of a harmonic oscillator cannot be 0, that have a value, that is half h cross omega. Meaning for this is for ground state. So for nth state, the equation can be written E mean n plus half h cross omega. For ground state n0 h cross omega. For E1 mean, that is from this relation we can calculate this. One case, if one take as delta x delta p, that is h cross, so one can get E mean h cross omega. This is nothing, h cross omega by 2 and h cross omega, both answer are correct, because in h cross by 2, that's a small value, h cross is small value, so that doesn't matter. I consider h cross by 2, so I get half h cross omega. If one can take delta x delta p, that is h cross, one can get E mean h cross omega, one can get E mean h cross omega, one can get h cross omega. So this doesn't matter. For nth state it can be written as E mean n plus half h cross omega. In my next video we shall discuss about in the next video we shall apply the uncertainty relation to find the ground state energy of hydrogen atom and helium atom both, because hydrogen atom has a 1 electron outside the nucleus and helium has a 2 electron outside the nucleus. So both the cases are different, and here we can in next video we shall discuss the mean ground state energy of hydrogen atom. So if you like my video, please subscribe my YouTube channel and like the video, and you can ask me any question, and you can free to mail me at this email address, moinak50physics@gmail.com. Here, and request to upload your requested video. I can try to upload this video as per your request. Thank you so much.